Hello everyone. Today we are going to learn about vectors in Rn, a fundamental concept in linear algebra and higher mathematics. The notion of a vector we'll know from two viewpoints, one mathematical and second physics point of view. So let's first start with mathematical definition. For that I am considering an example. Suppose there are some students and their heights are listed here in centimeters. So suppose I am taking 150, 152, 160, 156 and 154. Now I am denoting the values in the list by using one symbol. So for height I am denoting h. But I am giving different subscript to this. For example, I am writing h1 is equal to 150. That is the first number. Then again h2 as the 152, h3 for 160, h4 for 156 and h5 for 154. So this subscript denotes the position of the value in the list. For example, if we just randomly check that what is h3, so h3 means the third number in the list. Similarly h4 means the fourth number in the list, and so on. So such a list of values, if we write in this way, h equal to h1, h2, h3, h4 and h5 is called linear array or vector. Now, what vector means in physics? Many physical quantities such as temperature, speed have only magnitude. These are represented by real numbers and are called scalars. On the other hand, there are quantities, for example, speed, velocities, they possess both magnitude and direction. These are called vectors and we represent these by arrows from origin. So for example, we can write down, there is a u vector, we write down the u vector by joining this line to the origin. So this is the vector in physics. And also we give arrows to denote the vector in physics, like this one. Now let us check what is Rn. Rn represents n-dimensional real space, and this R is for real numbers and n denotes for the number of dimensions or the components. For example, when you are writing the R, that is the set of real numbers, we take any element from the set of real numbers. For example, 1, 2, 3, 4, then minus 1, half, root 2. So these are the elements from R. And how do we write that? We write set of all x such that x is from set of real numbers we have taken. Then if we just take R2, R2 is any element from R2, we can just write down, for example, 1, 2, then half, 3 by 2 in this way. So any element from R2 we write down as the ordered pair. So there are two numbers since it is R2. So we write down those numbers within a bracket and these are called ordered pair. We write down the R2 in general as set of all xy, where each x and y we have taken from the set of real numbers. In the same way, we can write down the element from R3. It will be, for example, 1, 2, 3. We can write down the set as in the same way. So this is the R3. Generalizing these things, we can write down the elements from Rn, which is, since in R3 3 components were there, in Rn it will be n components. So 1, 2, 3 up to n. And we can write down the in general set as, so n component has to be there, so that is why we have written x1, x2, xn. And each xi is been taken from R, where I is from 1 to n. So this is the element from Rn. Now let us just visualize, since we already know R2 and R3 elements. So R2 element, we all know that R2 means the two-dimensional space. So x, y, any element x, y, we can just take, it is a point in this two-dimensional space. Similarly, for the R3, we have to take, it is a three-dimensional space. So x, y and z, we can take any element from this three-dimensional space. This is a point in R3. Similarly, for the point in Rn also, since we cannot visualize, so I am not drawing any graph corresponding to this element. So the vectors in Rn will be the set of all n tuples of real numbers. Like we already have mentioned, the vectors list of numbers. So U is a vector in Rn. There will be n number of components in that vector, and every component has been taken from R, set of real numbers. And these are called components or coordinates or entries or elements of U. That is the vector. Note that here we have not given any arrow to denote the vector like we do in physics. It's absolutely okay if you are giving the arrows, but if you are giving the arrows, you have to give that thoroughly from the beginning to end. Otherwise, do not use that. Also, some other books, they have used Greek letter to denote the vector and use the English alphabet to denote the scalars. Some other books also, they have used the bold letters to denote the vector, and to denote the scalar they have used the normal font. But here I have not given any different notation, because a list of number is itself showing that you have written a vector. Now come to the null vector or the zero vector. If all the elements of the vector are 0, then it is called a null vector or the zero vector. Here, since 0 is an element, so to denote the vector, we can write the null vector or the zero vector by giving the bold, or also you can just write in this way to denote. This shows that this is the null vector. Whenever you are writing the vector horizontally, then it is called a row vector. For example, 1, 2, 3. Whenever we are writing the vector vertically, then it is called a column vector. Now generally, whenever we are writing the row vector, we denote the row vector by giving the first bracket, and whenever we are denoting the column vector, we usually give the third bracket. But some book, they have also written the column vector in this way also, by just writing the transpose, I think, to save the page or something else. But these two means the same. There are two important operations which are vector addition and scalar multiplications that are associated with vectors. So if we have a vector u and we have a vector v, both are taken from Rn, that is n dimensional vectors, then we can add the vectors in this way. We will add the first component plus the first component, then second component plus the second component, nth component plus the nth component. Then we can multiply the vector by a scalar, and the scalar will be multiplied to each of these component. So for example, here k into a1, k into a2, k into an. So this will be the multiplication rule with a scalar. Now these two vector u and v are said to be equal if both the vectors are from the same dimension, that is both the vectors have same number of components, and the second is if every corresponding components are equal. Here for example, if we want to check whether u is equal to v or not, we have to check whether all the both the vectors have same number of components. So u is also n dimensional, v is also n dimensional, so it's okay. And the second is every component has to be same. So here a1 has to be equal with b1, a2 has to be equal with b2, and in this way an has to be equal with bn. Now two more operations, dot product. Dot product is basically it will give a scalar number, and the rule will be the first component into the first component plus the second component into the second component plus nth component into the nth component. Then by finding the norm, we can find out the length of a vector. So the length of a vector we can just write down in this way: square root of dot product of the vector with itself, and that will give us the norm of the vector. Then let us understand the geometry of the vector addition. There are two rules. One is the triangle rule of vector addition. So here we have taken the a vector, which is denoted by OP. Then from here actually we have taken the b vector. So we have started the b vector from this point up to, so PQ is the b vector. Then the third side of this triangle will denote the addition of the two vector a plus b. Here since we have given a and b by denoting and giving an array, so R there will be an array. So this will be the R vector by the triangle law. Then the another is the parallelogram law. We are drawing the vector P from origin, so OA. We have drawing the vector Q from origin also, which is OD. If we complete this parallelogram, then the diagonal of this parallelogram will denote us the addition of the vector P and Q. Now the meaning of scalar multiplication. So if we have a vector V, then what is the meaning of 2V? 2V is basically we are multiplying the vector by 2, so its length will be double. Since we are multiplying the vector by a positive number, that is why the direction will be same. So only the length is double. Here also we have the vector minus v, so we have multiplied the minus v with 1.5. So that is why the direction will be same and the length will be 1.5 multiplied by v. Now if we have multiplied this minus v by minus 2, then the vector will be, the length will be double amount, but the direction will be changed. So direction will be in this way, and this will be the minus v into minus 2, that is 2v. Here it is same a vector, then minus 2v vector is given by triangle law. We can just write down the third side of this triangle will be the a minus To summarize, we can say a vector in Rn is just a list of n real numbers. We can add vectors, we can multiply vectors by scalar, we can take dot product, and we can find their length by using the norm of this vector. Therefore, vectors are fundamental building blocks in linear algebra and many other areas also. That's it for this introduction to vectors in Rn. In our next session, we'll explore linear combinations and spanning set. Thanks for listening.